Well, greetings out there in YouTube land and welcome to today's video. It's finally time to get started on the magnificent Rauland-Borg amp that was sent to us by Tom Fry. Let's get it out of the box and start to convert this into a world-class, hopefully, guitar amp. And straight from Nicaragua, honoring one of our favorite tunes, or I guess most of the tubes, if not all, and some other miscellaneous small parts. As you can see, we're dealing here with a Rauland-Borg Model RA32, which would lead you to think it may be rated at 32 watts of output, which should be rather generous. We'll see. Rauland's an interesting company in that it was started back in 1922. Okay, and unlike most companies founded before the Great Depression, it not only survived, but they're still in business. And Rauland combined with Borg in 1948, so we know that this unit was built after that time. And they still, to this day, make very sophisticated internal school and hospital communication systems. So hats off to Rauland-Borg for staying in business and for producing this gem that will be the feature of today's video. Okay, let's look down here at some of the unusual features of this amp. First is a rectifier that I have never seen or used before, a 5AS4. Let's look it up and see if there's anything special about it. Well, from what I can see, looking at the wiring diagram and the performance characteristics, it's very much like a 5U4. Nothing special. It's not like a 5AR4 where you're going to have a separate cathode and filament for your slow startup. This one is a directly heated cathode, so there won't be the slow startup feature that we appreciate from the other types of like GZ34 rectifiers. Next we'll travel down here to 6L6 GCs, and the ones that are provided are true beauties, RCA black plate 6L6s. Let's hope they're both in good shape and reasonably well balanced. Okay, coming back here we see another unusual tube, a 6AV6, and considering its position in between the preamp and the output tubes, I'm going to guess that it is the phase inverter. Let's take a look at what's going on inside of a 6AV6. And here it is, and it looks like a radio tube to me. Probably a surplus tube that was available at a low price. It has the triode, which is what will be used in this circuit, but it also has two diodes here on the side. Now this is used in radios sort of like a rectifier to eliminate the carrier wave so that the amplifier can then pick up the signal and amplify it. Okay, so obviously some sort of a surplus tube that was used in this amp, and my guess is as the phase inverter, the triode portion of it. And then the traditional 12AX7. Now, some other weird things. Input, but I noticed that there is an input jack on the back, a 1/4 inch input jack. We'll have to see if the impedance and all is correct. Perhaps this is just added in parallel with this input. Also, there is some weird polarized plug here, 1, 2, 3, 4. We'll have to figure that one out. And then an A, and since there is no output anywhere on this that I can see, this is probably the one designated A is for the speaker output. Okay, that'll be my guess, and I see that we have a plug here that will fit into this and has what appears to be speaker wires on it. So I'm thinking this will be our output. God knows what these are, and this will be our 4-tube amplification circuit, and then with a fairly traditional sort of a 5U4 clone rectifier. Also looking at the power transformer and output transformer, they are very stout. This is a, I think, fairly heavy duty, relatively high output amp. We'll see. I can attest to the mass of these transformers, having lugged this thing around a bit. Okay, and we see that the volume is located right here on the top rather than on the front or rear of the chassis, which would lead me to think, of course, that this is some sort of a PA amp. We'll see. Okay, that's it. No other secrets? Oh, an on-off toggle, which looks like it was added on. Okay, so that's it. Let's flip it over and see what the circuit looks like. Now, I get a lot of inquiries about how to do conversions on PA amps like this to make them the best possible guitar amps. So let's go through this step by step and discuss our observations and things like that. I think they will help you. First off, let's look at the input. Now, obviously, the input jack has been added, and it is in parallel with the input jack that was that came on the amp. Okay, now there's other things we need to notice here, and that is the input then will come down here. It comes across to the volume control and then directly into the grid of one of the triodes of the preamp 12AX7. Now, you know that's not the best setup. First off, to have the volume control on the input signal is not a great idea. Secondly, there is no grid stopper, or the grid leak is actually going to be through the volume control in this case. So it exists. But this is just not the optimum setup for guitar use. So we're going to have to go in here and modify this. Also, the volume control is generally better placed between the first and second amplification stages. Okay, so we might want to change the circuit to move the Gibson volume control here to a more advantageous place. Now let's take a look at that mysterious socket that we saw on the top. It was 1, 2, 3, 4, and we had this weird little plug to put in here. Now, if I tell you that it is in between the B+ output of the rectifier and the first filter cap, what does that bring to mind? Maybe like a standby switch? So I'm thinking this right here was probably a remote, sort of like a standby switch to silence music or other things that were being played through the PA amp so you could make announcements. I'm going to bet that's the case. Okay, so this then is some sort of a remote standby switch. That's my guess right now. We'll see later when I get deeper into this if that theory holds up. And when we look at the bottom of that 6AV6 tube, we see that it is indeed a cathodiene phase inverter. The triode plate and grid are being used for phase inversion, and since it is a radio tube with those 2 extra diodes that are not used in an amplifier circuit, right here and here are the pins for those diodes. Normally, when these aren't used, they're grounded. In this case, they're not. Now let's try to interpret what's going on with this output transformer. See that the B+ comes in here. This will be the center tap then of the primary. And we have the 2 plate outputs, one to this 6L6 and one up here to this 6L6 plate. So far so good, but there's a couple other extra outputs. This one here has been removed from the circuit or never was connected to the circuit. This black output wire and the large number of secondary outputs are somewhat puzzling. They all come over here and seem to communicate with this socket, which I think is a speaker output socket, but it may have different impedances. So I think what I'll have to do is determine the winding ratio of this output transformer between the primary and secondary, and then pick the 2 outputs or 3 that suit, like a 4 and 8 and maybe even a 16 ohm secondary output. but it's going to take some mapping then of this output transformer so that we'll know the proper wires over here to be using for our speaker output. Now the secondary leads here from this output transformer go all over the place. Most of them though end up over here at this what I think is a speaker output socket. Now whenever I'm confronted by a bunch of extra wires that go places that I have a hard time understanding, I think it best to disconnect all of these secondary connections and then do an analysis of the winding ratios between the primary and secondary of this transformer, and then figure out which of these wires produce the impedances that we can use, and then rewire it to suit our purpose. So I'm going to disconnect all the wires from the speaker output socket, from this what I think is like a remote standby switch, and down here by this input. And I'm going to then perform the winding analysis and then rewire, not using any of these three original connections. In fact, I think I'm going to go so far as to remove these three sockets and then cover the holes over with an aluminum plate on the top of the chassis. Okay, I have disconnected all three of these receptacles, and all the wires have been removed. You see here's one that's a B+ wire, and there's all kinds of output transformer secondary wires flapping in the breeze. There are those two extra wires that I hypothesized might be for ultralinear screen connections. Oh, and check this. This is a sweetheart here. Okay, and without having any sort of schematic to work by, I'm just going to take this thing back down to basics. I'm going to figure out what each of these wires does, and then I'm going to use the ones I need, disconnect the ones I don't, and make just a really good, basic, functional guitar amp out of this, with no extraneous parts or wires. Alright, step one is completed. All three of those extraneous parts have been removed, along with a bunch of extra wire that I don't anticipate needing. Okay, so now I'm going to cover these holes with a flat aluminum plate on the top of the chassis so that it retains a nice appearance. Now it's time to install the brushed aluminum plate over the three holes in the chassis. So here's before and there is after. I think a whole lot neater. Casey, you hungry? You want breakfast? Ah, always hungry. So to map this output transformer, you remember that the primary side has high voltage, the secondary side has low voltage. I have connected the variac to the primary side, and I'm going to crank in sufficient AC voltage until I get exactly 1 volt out on the secondary. And this is a graph of the results. The wires are numbered arbitrarily. I had to do something to identify them, so these numbers were just put on randomly. But this is the way it looks. On the primary side, we have the orange and gray going to the plates of the two 6L6s. The white comes from the B+. Now from wire 3 to wire 1, I found that there was a 32.2 to 1 voltage and therefore winding ratio. If you square it, you get the impedance ratio. You see from 3 to 2, I get 24.5 volts, which squared is 600. That's the impedance ratio, and on through. The 6 and 7 were a separate winding. Now, you know from my previous video, if you multiply the impedance ratio times the impedance of the speaker, then you will get the reflected impedance back over here to the 6L6s. And the proper reflected impedance for a pair of 6L6s operating at around 360 volts is going to be around 4,000 to 5,000 ohms. So as you can see, with this as the impedance ratio, 1037, when I multiply times 4 ohms, I will be in that range. So 3,1 is going to be the 4 ohm output. Between 3 and 2, I got 600. If you multiply that times 8 ohms, you're at 4,800, which is right in the proper range. So 3, 2 will be the 8 ohm output. These others are just not appropriate for any normal speaker impedance, and they probably were for some sort of PA speakers or chain of PA speakers or something of that sort. So we will ignore all of the connections other than 3.1 for 4 ohm and 3.2 for 8 ohm. So here I have the 3.1 that's going to be my 4 ohm output, and 3.2 will be my 8 ohm output. I'll have to wire these up to output jacks on the chassis and label them properly. Remember, that's the input there. Maybe I'll have the outputs over here. I'll have to figure out a safe place to put them, and we'll have them 4 ohm and 8 ohm output. The other wires then will be insulated, wound up, and saved for a rainy day. Alright, I've cut the extra wires from the output transformer to a more reasonable length, insulated all the ends, and then fasten them over here to the side of the chassis so they're out of the way. Next, we're going to drill the chassis and install 2 speaker output plugs for 4 and 8 ohm output. I'm also going to remove this rather unwieldy orange power cord because it really interferes with me moving the chassis around. And I notice it's rather strange, but the ground wire connection has been cut, and I don't know why that would be. But let's go ahead and remove it, make this thing easier to manipulate. Now I've added 2 output jacks here for the speakers, and this one is going to be the 3.1 for 4 ohm, and the 3.2 over here for 8 ohm. And I've labeled them just crudely at first, maybe better later, just to keep them straight. Okay, then let's start wiring our input circuit properly. Alright, step 1 here on the input circuit. I've installed a self-grounding, that means that extra leaf in there, that grounds the contact when there's no 1/4-inch jack plugged in. And it's ready to be wired. This will be where the input signal will come in from this big leaf, and we're going to send it, instead of going directly to the volume control, we're going to go to the first stage here of the 12AX7 preamp tube, and then we will run from that stage to the volume control and then back to the second stage. I'm going to draw up a real quick schematic to show you what it's going to look like. Let's look at this hand-drawn schematic that I whipped up quickly and see how the circuit compares with it. Here is our input jack with the leaf that brings our signal in through a 68K grid stopper to the grid of the 12AX7, which will be pin 7, and then 1 meg grid leak. We look over here. Here is our 68K coming in from the contact leaf of our jack, and it goes right down here into pin 7 of the 12AX7. Over here is the 1 meg grid leak, which goes from the signal to ground. Next we'll look at pin 6, which is the plate of that first triode, and we see that we have our B plus coming in through a 100K resistor, and we have our signal coming out through a 0.047 microfarad cap to the center lug of our volume control. And here is pin 7 right here. You see that there is our 100K resistor bringing in the B+, and here's our 0.047 microfarad cap delivering the signal from the plate to the center lug of the 500K volume control. Then from the volume control, the signal will have two choices depending on the position of the pot wiper. It can either go to ground or it can come over here and enter pin 2 of the second triode of that 12AX7. Okay, that lug right there goes to ground, and this one over here comes over to pin 2 of the second triode. That'll be the grid. So it's going in now, it's been controlled by the volume control, and it's entering the second stage of amplification. Before continuing, I want to make the following correction to the connections on the volume control pot. I found through experimentation that this works better. If I reverse the input, instead of going to the wiper of the pot, go to the right hand lug. So this is the input from the first triode through the coupling cap. Then the wiper goes to the second triode grid. The left hand lug is still grounded. So I found that by reversing these two connections that the volume control functioned better. Then from that second triode it will exit from the plate, which is pin 1. We see the B+ coming in through 100K resistor, and we'll pass through a 0.047 coupling cap into pin 1, or the grid, of the 12AV6. And we see here is pin 1, and here is our 100K plate resistor and our 0.047 microfarad coupling cap that delivers the signal right down here to pin 1 of the 12AV6. So the input circuit and two stages of the preamp circuit have been wired properly with the volume control in between those two stages. The signal has now been delivered over here to the phase inverter, where the plate will send a signal to one of the 6L6 grids, and the cathode will send an out of phase signal to the grid of the other 6L6. Now that the input, preamp, volume control, and output are all rewired to be correct, it's time to start looking at the filter capacitor situation here, and it sure seems like there's a bunch of them. I'm not sure if all are necessary. Let's dissect this part of the wiring and see what we really need. First, I made a diagram of that big can capacitor and what connections went to what terminals. Then I removed all the wires and extracted the can capacitor and was dismayed that there were no values printed anywhere on it. But then I found that the sleeve, the cardboard sleeve, could be removed to show all the different values. So we're in good shape here. What I'll do then is consult my diagram and reconnect each of the wires and resistors in the proper position to maintain whatever the B+ circuit was originally. Of course, I'll check it to make sure that it's appropriate, but I have a feeling it will be. Well, the entire power supply has been rewired. Let's trace it and see how it looks. This is pin 8 of the rectifier, and you see that we have the 40 microfarad cap to ground. Then the B+ comes around here on the red wire to this terminal strip, which I transplanted. I drilled the rivet holding the strip up here and just moved it down to here. Okay, here comes the B+, and it goes through a 3000 ohm ballast resistor to be dropped down to proper level of voltage for the screens of the 6L6s. The second nodal capacitor here is a 22 microfarad. Then we travel through this 10K resistor to the next node, which has its own 10 microfarad filter cap. Follow this wire from that node, and we're feeding the plate of the 6AV6 phase inverter. We come off of that with a 22K resistor, and we come down here to this node, which has its own 10 microfarad cap, and we feed both of the plates of the 12AX7 preamp tube. I think things look a lot neater and more businesslike without that terminal strip up here in our faces and that black cardboard wrapped can capacitor hanging down here. It looks more like a point-to-point vintage amp now. Next step is going to be to determine how the 6L6s are biased and to be sure that they are biased properly. And much to my surprise, as I look at pin 8 here on the 6L6s, they are linked together by this black wire, and the cathodes are grounded. Okay, no wonder this thing claims 38 watts of power. This has a separate negative DC voltage supply for biasing the grids of the 6L6s. So one more element here for us to check and be sure that it's functioning properly. Well, I've replaced the 8 microfarad at 50 volt filter cap for the bias supply, making sure that the positive end went to ground, since this is a negative DC supply. Next, I've hooked up a probe to the grids of the 6L6s, and I've connected the primary of the power transformer here to my trusty Variac. Let's see what kind of negative DC bias voltage we're getting from this bias circuit. Well, what, 27.6 volts negative DC. Let's check a tube chart on 6L6s and see if that's an appropriate bias voltage. Well, looking at our average plate characteristics chart, it appears to run from 0 to negative 30 volts. So it looks like we're right in the range here. I think, I might even make this a adjustable supply just for the fun of it while I'm in here to assist in making the biasing a little easier. It appears that the voltage limiting resistor is right at about 25K. So that means I need to come up with a combination of a fixed resistor and a pot. And I'm thinking, a 10K fixed resistor, 25K pot. Let's wire that in here and see if it works. Well, here's our negative DC bias supply with an adjustable bias control to make things a whole lot easier when it comes time to biasing the 6L6 output tubes. Here's Jack taking his afternoon nap on his favorite blanket. It's kind of fuzzy and reminds him of his mama. Jack, are you ready to come out in that hot stuffy workshop and help me with this video? Come on. Jackie? Boy, you remind me more of Rusty every day. Alright, time for a quick review here. We have completely rewired and redesigned the input circuit with the volume control placed between the first two stages of preamplification. We have replaced all of the filter caps. We have mapped the output transformer and created 4 and 8 ohm outputs with all the extraneous secondary wires bundled and insulated. The negative DC power supply for biasing the grids has been altered with a potentiometer so that it is variable and adjustable, and a brand new power cord here has been installed which securely grounds the chassis, and with the hot wire traveling through the on-off switch and fuse as it should be. Now I think it would be interesting to flip this over, bias the output tubes and then test it to see how it sounds. Now with the chassis on its side so that I can reach in and adjust the bias with the knob here, we put the Eurotube's test probe under the upper 6L6, and we'll take readings of the plate voltage and plate current. And as you can see, by turning the knob I can adjust the plate current. I'm going to run it up to 39 milliamps at 421 plate volts. That's on the upper 6L6. Now with the Eurotube's probe under the lower 6L6, we'll get readings from it and compare them while we're waiting for the Eurotube's probe to stabilize. I wanted to draw your attention to the fact that to protect my output transformer, I have installed an 8-ohm dummy load across the 8-ohm speaker output. Okay, things have stabilized pretty well here. We've got 44.3 at 425 volts. Higher. Let's write these values down and see what we get for plate dissipation. I gave that second tube a little more time to stabilize, and the value for plate voltage and plate current came down a little. So I used these more stable values, but you see that the plate dissipation then on the upper tube 16.4 watts, bottom tube's 18.4 watts, for a mean of 17.4 watts of plate dissipation. Now the maximum is 70% of 30 watts for a 6L6 GC, so max is 21 watts. I find this value to be comfortably beneath the maximum, but yet warm enough to give us some good stout output from this amplifier. Okay, now that we have checked the output tube bias and adjusted it to a safe level, and we've verified that the voltages within the circuit are all appropriate, let's button this jewel up, plug in a guitar and a speaker, and let's see how it sounds. Well, we're out in the workshop now with the mighty Rauland-Borg amp, all fired up and ready to be tested. We've got Jack and Ollie tuning up right now and getting ready to put this little jewel through its paces. So sit back, grab your beer, and see what you think. As a result of the audio testing, I thought it would be a nice addition to put in an adjustable negative feedback control. Now, what I noticed is at very high volumes, there was a bit of flubbing that took place. So if that's the case and you want to operate at real high volume, you can crank in some negative feedback with this control to increase the headroom a bit and to clean up this. To create this negative feedback control, I ran a shielded cable from the 8-ohm output to the speaker over here to the center tap of a 50K pot. Then to this lug I ran a 10K resistor into the cathode of the second stage of amplification. Now when you turn the pot, you can adjust between 10K and 60K of resistance in your negative feedback loop, essentially turning it on and turning it off and controlling the degree of negative feedback which is returned here to the cathode of the preamp tube. You know, I was so impressed by the tone of this amp when I was testing it that I just couldn't leave this front control panel just that old rusty, dingy metal. So I fabricated a brushed aluminum strip here that has the input, output, and on-off switch holes, and I think really that it's going to make it look a lot better. I also sanded and painted this gold so that there would be a nice even contrast. Here's that polished aluminum strip in place on the front of the amplifier chassis, and I think it does pep it up. It certainly labels the input and output very clearly, and I think it adds to the appearance of the unit. Then, as my final token of respect for this fantastic old amp, I've mounted it on a wooden plank so that the chassis is sealed, and that will eliminate any shock hazard of anyone reaching underneath, like when you're picking it up or something and getting shocked. Also, I put small old-fashioned rubber feet at all four corners so it sits up a little bit off of the tabletop, and it's now finished. So you've heard it play, you watched everything that went into making that happen, and there was a great deal. And I want to tell any of you who are contemplating doing some sort of a conversion of a PA amp to a guitar, don't be put off. This one is probably the toughest I've ever had to work on. I had to really essentially just redesign the entire circuit. So believe me, most of them aren't this difficult. And there you have the finished product, the astounding Rauland-Borg Model RA32, claiming 32 watts of output power, and I think backing it up pretty well. I thought the final sound from this jewel was absolutely wonderful. Really rich bass response, clear treble, just what I'm looking for in a guitar amp. I certainly hope that you enjoyed the journey and the final arrival at our destination. I want to thank all of you who have subscribed to our channel and our Patreon patrons and PayPal contributors, all of whom keep us on the air, cranking out videos like this every month. If you would like to join them, I'll have links in the video description to help you to do so. You can also feel free to contribute gear like this to our channel to be featured in future videos. With that said, I wanted to be sure that you stay tuned for an added special feature. With minimal effort, I managed to get the Legend Rock and Roll 50 amp up and running. And let me say, based on the number of restraining orders and disturbing the peace complaints that were lodged against me by neighbors in about a mile radius, it definitely lives up to the hype with regard to volume. If you'd like to see Jack and Ollie put it through its paces at volume levels that are beyond the threshold of pain, then by all means stay tuned. If not, or regardless, we hope to see you again in future videos. Bye for now.